Okay, a few reminders before we go ahead and get started. On Monday, don't forget we have our next quiz. It's a CFA quiz, which means you'll be putting your answers in via the Chromebook. I'm going to grade them by hand this time because some of those are not multiple choice. They're open-ended. It is over law of sines and cosines, as I've been stating. The big item is next week, just under a week away on the 21st. That's when you have your first exam, right before Thanksgiving. You can use a 3x5 note card. In fact, I would encourage you to use a 3x5 note card because there is a lot of information on the test. The ambiguous case for side-side angle, the formula of oblique triangles for side angle side, and Huron's formula, law of sines and cosines, along with all the graphing information. Okay, so there's quite a bit on there. And the only other item, don't forget next period at the beginning, Mr. Anderson should be coming on the overhead speakers and very quickly saying we're going to have a fire drill, and that's pretty much this week. Any questions about anything coming up? Okay. Well, let's continue with this particular lesson. So a couple days ago, I walked you through tangent. Yesterday, Mr. Yacht, he went ahead and walked you through cotangent here, and he worked a couple problems with you. And while I'm thinking about Mr. Yacht, I'll go ahead and tell you in the spring semester, the second semester, we are going to be receiving, at least as of right now, a full-time student teacher. Unfortunately, it will not be Mr. Yacht. I went and talked to the supervisor and said, hey, he's already familiar with the students and the classroom policies and everything, could we go ahead and keep him here? And she said, well, I like to switch the students around so they get, different classrooms, different opportunities to learn. So we are going to be getting a student teacher, but it will not continue to be Mr. Yacht. So kind of good, bad news there. All right, so let's talk about secant and cosecant. All right, so like every other graph, we got some characteristics. I'll let you copy those down very quickly. And remember, on several of these, we're referring to a value k. K is just an integer. That refers to your positive counting numbers, their opposites, and 0. Okay, an integer is not recognized as a decimal or a fraction. Thank you, ma'am. Should not take us too long to go ahead and do a couple of these examples because graphing secant and cosecant are actually much easier than you would think. Okay, so the cosecant and secant functions are reciprocal functions of both sine and cosine. They are going to have the same periods as before, 2 pi radians before they go ahead and repeat again, and they're going to have asymptotes just like the previous two graphs. Now we can use this concept as an aid in graphing. Each reciprocal function behaves as a sort of skeleton for the graph in question. So if you feel really comfortable with the graphs of sine and cosine, graphs of secant and cosecant are going to be really, really easy for you. In fact, I started by saying that cosecant of x is equal to 1 over sine of x. Very similar to what we did with tangent and cotangent. Remember, cosecant's ratio is the radius over y, right? But if we're on the unit circle, what's the length of the radius? 1. While y is what we associate with the trig function sine. So just like we did with sine over cosine for tangent and so forth, we can do the same thing here. Now, I'm going to use sine to help me figure out what cosecant's going to look like. So I'm going to start by graphing that. Remember, sine always starts with a 0. Then we have a maximum, 0, minimum, 0. I'm going to go ahead and graph this across the grid. Now you want to draw this lightly. There we go. So there's sine. Okay. So wherever sine equals 0, that's going to be a problem for cosecant. That's where cosecant's going to be undefined. So where is sine 0? Everywhere the graph does what? Touches the x-axis, and I've got several locations here. So negative 2 pi, that will be a asymptote for cosecant, as will pi, 0, pi, 2 pi. So we know where cosecant has all the asymptotes. Now, what we're going to notice are branches that open away from where the graph of sine is. In fact, these begin at the maximums and the minimums of sine. So everywhere sine has a maximum or a minimum, we're going to have a branch that opens away from that point. So here I have one that opens up, opens down, opens up, opens down. Now I'm going to go back and I'm going to erase the graph of sine. And what I have left is cosecant. See, I can get the entire graph of cosecant by knowing what its reciprocal sine looks like. And there we go. So like I said, the period of this function is going to have 2 pi radians. Now, a period is going to contain both an upward and a downward opening branch. Now, they look like what? They look like parabolas, okay, but we don't want to refer to them as parabolas because they're not constructed in the same way. So that's why I'm referring to them as branches. They're parabola-like, but they're not parabolas. Okay, and you can go ahead and start comparing this to the information we have here. The domain is every x are all reals except multiples of pi. All right, that's where the asymptotes are going to be located. Remember, sine had range from negative 1 to 1. But here, the range, there's nothing between negative 1 and 1. It only exists above and below. Okay. And any questions? Pretty straightforward. Okay. So I'm going to get the graph of secant in just the same way. So if cosecant is 1 over sine, then I'm going to say secant is 1 over cosine because, again, I'm using that ratio where the radius is 1 and x is cosine. Okay, so where does cosine begin? He begins with a maximum. Okay, so a maximum, 0, minimum, 0, max. And then we're going to go back in the other direction. There we go. So here is the graph of cosine. And just by knowing this, we are immediately going to be able to tell what the graph, the parent function for secant looks like. So where do you think secant's asymptotes are going to be? Okay, what's that, Will?
0.
Yeah, wherever cosine touches the x-axis, because we can't have 1 divided by 0. So it looks like I have one at negative 3 pi over 2, negative pi over 2, pi over 2, and then 3 pi over 2. Okay, where am I going to have the branches that open upward and downward? At the maximums and minimums that cosine has. So here's a maximum, so I got a branch that opens up. Minimum, branch opens down, maximum up, minimum down, maximum up. And it's the same idea. Okay, the period is going to remain 2 pi radians. Okay, a period is still going to contain an upward and a downward opening branch. And then let's go ahead and erase cosine. Bless you. And there we go. That is the graph of secant right there. And now I'm not going to worry about it, but you can go back to the unit circle and start plugging in these radian measures. Like if you plug in 0, secant should give you 1. If you were to plug in pi over 2, secant should be undefined. And you should be able to check a lot of those points on the unit circle if you'd like. Okay, any questions on these graphs? Okay, well, let's go ahead and transform one of these. Okay, next example. Graph the function, its reciprocal, state the period, and show all asymptotes. So I want to graph y equals 2 cosecant of x over 2. Now, here's why graphing secant and cosecant are going to be so easy. You see how we got the graph of the parents using their reciprocal? We're going to do the exact same thing here. We're going to graph the reciprocal and then use that as the skeleton to get the graph that we want. Okay, so instead of graphing 2 cosecant x over 2, I'm going to graph 2 sine of x over 2. I'm just going to replace the trig function with that reciprocal trig function. Okay, so see, we already know how to graph sine and cosine, so there's really not a whole lot of new information today. All right, let's start with the horizontal. In fact, what do I put x over 2 between for my compound inequality? Between 0 and 2 pi, okay. So I'm going to say 0 is less than or equal to x over 2, less than or equal to 2 pi. Now, sine and cosine are between 0 and 2 pi. Does anybody remember tangent is between what two boundaries? Negative pi over 2 and pi over 2. Now, cotangent is between 0 and pi. Here we go. Well, how would I simplify this and just get x in the middle? Let's multiply through by 2. Okay. Which would give me 0 less than or equal to x, which in turn is less than or equal to 4 pi. Okay, so these x's are ready to go. Okay, we simplified the inequality just like we had before. Now I'm going to turn my attention to the y values, the vertical. Because we're graphing sine, what was that combination of ones and zeros? Sine started with a 0, then a maximum, 0, minimum, and then back to a 0 again, right? Is there anything happening outside these parentheses? So what am I doing with that 2? Am I going to add, multiply? There you go. This entire graph has a vertical expansion by a factor of 2, a vertical stretch. So because the 2 is outside the parentheses, I'm going to multiply each of those by 2. So 2 times 0, 2 times 1, times 0, times negative 1, and then again times 0. Is everybody okay? So these are the y values that I want to use. Okay. How would I pair the x's with the y's so I can start getting ordered pairs?
Start with your 0.
Okay. So the lower boundary will always go with which y? The first one. Okay. The upper boundary will always go with the last one. Okay. Now this is where most people have been having some issues. What are the steps to fill in those missing x's? Okay, so Noe says subtract 0 from 4 pi. Okay, so 4 pi minus 0. And then do what with that? We always divide by 4. So in this case, it's just pi. Okay, so now how does that pi help me fill in those values? There you go. We just start with that lower boundary, and we just start adding it over and over again. So what's 0 plus pi? Plus pi. Plus pi. There we go. And now I've got 5 points on 2 sine of x over 2. All right, so let's go ahead and plot those. We got 0, 0. Then we have pi 2. Then we have 2 pi 0. Then we got 3 pi negative 2. And we got 4 pi 0. Okay. And I got more than enough room to go ahead and put another period on here, so I'm going to go ahead and do that. The next one should be at negative pi negative 2. Then where? Negative 2 pi 0. Then at, there you go, and negative 4 pi 0. So remember, we're going to draw this lightly because we're not actually wanting this graph. We're using this graph to get the reciprocal. Okay, so this is 2 sine of x over 2. That's something we've been doing for a while. Any questions? Okay. Now, think about what we did when we got the parents. We used the original graph to tell me where my branches and my asymptotes were. So I'm going to use this transformed graph to do the same. Okay, where are my asymptotes? Everywhere this graph does what? touches the axis. So I have negative 4 pi, negative 2 pi. There's 0, 2 pi, 4 pi. Well, how do I know where to put my branches that are opening up and down? Every maximum and minimum that this graph has. So maximum opening up, minimum opening down. Maximum up, minimum down. So when I erase 2 times the sine of x over 2, what I'm left with is 2 cosecant of x over 2. And there we go. Okay. The formulas, all the original formulas are now the same. Okay. Only tangent and cotangent will have periods of pi divided by b. So this one here is still 2 pi divided by b. Well, what's b in this case? X. Ooh, we don't want to use the x though. 1/2. So let's see. If I were to say 2 pi divided by 1/2, that would give me 4 pi. And see, not only do I see that in my compound inequality from 0 to 4 pi, but if I look at my graph, it has a 4 pi radian distance. Because remember, one period of these have to include both the upward and, bless you, the downward opening branch. And that's it. That's all there is to it. So really, it's just almost more practice with sine and cosine, and then these graphs are just a result of that. Any questions? Anybody having a hard time? Okay, Solandra, good. Oh, you were raising your hand? Okay. Okay, then that's all I had for today. I was going to go ahead and stop early because I wanted to start grading. It looks like we got about 8 or 9 minutes left, so just relax.